This is our sixth and final video. We started off our journey on the definition of reliability, and then we touched the type of data that we're likely to encounter in reliability engineering. We discussed some of the models to analyze our data, and we looked at a way of improving our estimates via confidence bound. We then looked at the data points on the graph and what kind of information we could provide from that. We're now on the home straight, and what is left is to present the results of our analysis. So we've done our analysis, and now we look at the graphical output. We're not going to discuss again whether this model is appropriate or not for this type of data, but what type of information we could collect from this plot. This plot is the probability of Weibull, and the type of information is the probability of failure. So we'll be able to extract any information in terms of probability of failure after specific time. Or we could look at it on a positive domain and look at the reliability graph and extract the probability of survival or the reliability of our product after a specific time. And of course we could apply confidence band to that chart. Or we could look at the PDF or probability density function, but this type of information, it's only to look at the shape of the distribution. We are not going to extract numerical output from here. The probability density function works in terms of area. And then we could look at the failure rate. The failure rate is not a particularly useful type of graph in so much, again, here we wouldn't be looking for some specific numbers simply because it's a variable unit that changes with time. So we will be looking more at a trend, but we could define that trend by just looking at the parameter. In this case, we're close to 2, so we know there's going to be a straight line. And then we have the contour plot. And the contour plot just shows the variation of the parameter. Here we have the shape parameter, and here we have the scale parameters, and we can see the variation of our parameter. And obviously these values that we've obtained from our analysis are the median values. And we can see the contour plot also measured against the likelihood ratio, the likelihood surface plot. Again, that shows the coordinate of our parameters. Then another graph that we could explore is the mean remaining life. The mean remaining life tells us what is the expected life of our product after it has already accumulated successfully a certain number of years. And we read it from the x-axis to the y-axis. So both axes contain time as coordinates. And the last one, perhaps just for this specific analysis, we could look at this FS timeline. We have all our data points of failure, and here it tells us the timeline of all our failure. And if we change the scale to match the scales of the reliability, and we can just view also the reliability graph, we can see that that matches quite accurately this FS timeline. And but if we go back to the previous chart, we can see that this part clearly indicates that perhaps there was an opportunity to insert a shift in our distribution. And this is as far as sort of the graphical output of our analysis. And if we obviously want to extract detailed information, a detailed numerical answer, then clearly we can refer to the quick calculation pad. We can interrogate in terms of reliability, probability of failure, conditional reliability, and in a sense conditional reliability is something that we haven't seen on our graphs. And conditional reliability or conditional probability of failure requires 2 mission time, one that we successfully completed, and in this case, like for example 15 years, and what is the probability of success for another 25 years. And this is the technique that is at the base of warranty analysis, effectively. So we have a product in the field that has already accumulated a certain number of years. What is the probability that will survive for another number of years? And that concludes this very brief introduction to this life data techniques and Weibull Journey. Please check out on the link on the screen if you would like to go deeper in mastering this analysis, and we're very happy to help you or answer any question you may have. Thank you, it's been a pleasure.